Hello everyone, in today's session we will discuss about numerical problem on AC and DC distribution system. So in this we will calculate voltage drop calculations by taking one numerical problem on DC distributor. In previous session we have seen a numerical problem on DC distributor which is fed at only one end. The second end is not feeding any voltage. So in today's session we will see a numerical problem feeding at both ends, that is at end A, it is feeding, and it is at end B also it is feeding some voltage. So where will be the minimum voltage occurs in the DC distributor, we will calculate. So if you see a problem, a numerical problem which is given like this: AB distributor which is of 600 meters, and at end A 220 volts is feeding, and at end B 220 volts is feeding. So if you see it at different distances, AC is 100 meters, a tapping of 20 amperes is happening, and at CD at point D 40 amperes is tapping, at point E 50 amperes, at point F 30 amperes. And the distance or AC distance is 100 meters and is given CD is 150 meters and D is 150 meters, EF 100 meters, another is 100 meters. So totally the total distributor length is 600 meters, and it is given that the cross section of the distributor is 1 centimeter square. Cross section of the conductor is 1 centimeter square, and the rho value is given as 1.7 into 10 to the power of minus 6 ohm per centimeter. So to calculate resistance of different sections, section AC, section CD, section DE, EF, all sections we have to calculate resistance value. For that we need to calculate resistance of the conductor by using this formula, rho L by A. Rho L by A is a formula which gives resistance of the conductor, providing rho value is provided in the numerical problem, and length of the distributor is given and cross section is given. If you substitute all these values, that is 1.7 into 10 to the power of minus 6, this is rho value, and the length is 600 meters, we have to convert it to centimeters, this is 10 to the power of minus 2, because it is completely given in centimeters, we can make it in meters also. So and A value is given as cross section area of the 1 centimeter square, it is given as. So by taking all these, finally we will get rho value as 0.204 ohm resistance of the conductor, ohm per centimeter it is, because we have taken all the values in centimeters. So we can convert this into meters also. Depending on the situation we have to take the values either in centimeters or meters, anything. So I think it comes under per meter, it is not centimeters, it is per meter. So first we calculated resistance of the distributor given as rho value, length of the distributor, cross section of the distributor. By taking these three values we calculated resistance of the distributor per meter. So after that we have to calculate RAC, RCD, RDE, REF, RFB, like this. Resistance of the distributor in each section resistance we have to calculate. So per meter we got it as 0.204, AC section length is 100 meters and 0.204, CD section length is given as 150 meters, DE section given as 150 meters, EF section is 100 meters again, and FB section is again 100 meters. So like this we have to calculate the resistance of each section, resistance of each section. So RAC comes around 20.4 ohm, 20.4 ohm, and this comes around 30.6. So like this again we can calculate 30.6 it is, and it is again 20.4, and this is also 20.4. So these are the resistance values of each section, resistance values of each section. First we calculated resistance of the distributor by taking rho value, L value and cross section area as 0.204 ohm per meter. So later on we calculated resistance of each section. So after this we have to take the currents in each section. So IAC, I will take it as IAC or IA. This is IA current feeding at NDA, current feeding at NDA. So from that, if I need ICD, if I write ICD like this, it will come ICD current. ICD becomes IA minus 20, because 20 amps is tapped at section C. So that IA current minus 20 amps will go into ICD. Next IDE current. IDE current we can take it as already IA minus 20 is flowing in ICD section. From that a 40 amperes is again drawn. 40 amperes is again drawn. EF section, similarly EF section. Next FB section. From this IA again minus 20, minus 40, a 50 amperes is drawn. Again like this we have to take current in each section, minus 20, minus 40, minus 50, minus 30. This is 30 amps is drawn at F minus 30. So these are the currents. We can simplify this. It becomes IA minus 20 as it is. This is IA minus 60. This is IA minus 110, and it is IA minus 140. So these are the currents at different sections: IAC, ICD, IDE, IEF, IF. Like that we calculated currents. So next, if you write voltage drop between VA, voltage difference between A and B points, this comes around the current IA and resistance of AC section plus, that means VAC plus VCD plus VDE, VEF, like that we have to write. So to write for ICD section we will write current ICD RCD, ICD RCD plus this one IDE. Next section is IDE. IDE multiplied by RDE plus next section is IEF multiplied by REF plus IFB multiplied by RFB, like this. So voltage difference between A and B points, can be written as VAC, VCD plus VDE plus VEF, VFB. So like that we have taken all the voltage drops throughout the distributor. So if you see VA minus VB, so VA is also feeding 220 volts and VB are also feeding 220 volts. So this value becomes 0. IA we don't know, we will keep it as it is. RAC already we calculated, that is 20.4, it is 20.4 RAC value plus ICD is taken as IA minus 20, IA minus 20. From this RCD value is taken as 30.6, it is 30.6. Already we calculated resistance of each section. ID is again IA minus 60, it is IA minus 60 multiplied by RDE, RDE is 30.6, it is 30.6 again. Next IEF is IA minus 110 multiplied by 20.4, it is 20.4. Next plus this is IFB, this value IA minus 140 multiplied by again 20.4. So these are the substitutions from previous calculations, all calculations. So from this directly we will get IA value as 61.66 ohms, 61.66 amps. So these are the current feeding at point A. So by back substituting all these values in this we will get ICD as 41.66 amps, and next one 1.66 amps, and next minus 48.34 amps, and next minus 78.34 amps. So these are the currents in different sections. So if you observe closely, the IEF and IFB, these two currents we got it as negative. That means we considered all the directions like this while calculating all the directions like this, but IEF and IFB we got it as negative. That means current actually flowing in this direction, we got it as negative. So that means we can say, so finally this distributor feeding point is feeding current like this, and this end it is feeding current like this. Finally the currents will flow at point E like that in the two directions, By this we can say, so there is a minimum voltage point in the distributor, that is at point E. To calculate point E voltage, we can take it as VAE. VAE can write it as VAC plus VCD plus VDE. AE can be written as VAC plus VCD plus VAE. Similar fashion, already we have taken VAC voltage means this is VAC voltage, and this voltage and this voltage. If you add up these three, we will get VAE. The VAE comes around minus 23. It comes around 236.3 volts, minus 236.3 volts. So that is the minimum voltage at point E. Like that we can calculate by using this. So this is the simple numerical problem which is feeding at both ends, at end A, at end B. So initially in some numerical problems they may given resistance value directly, they will give resistance value directly. So if it is given directly, we can as it is we can calculate, otherwise they will give rho value, L value and A value. By that we can calculate resistance value. So after resistance calculation, each section resistances we have to calculate. What are the resistance values of each section? After that we calculated currents by assuming current IA current is flowing in at the beginning. So from that 20 amperes are drawn, after that 40 amperes are drawn, after that 50 amperes are drawn, after that 30 amperes are drawn. Like that different sections, different currents are drawn. So by taking this VAB difference, voltage difference between A point and B point, we take it as VA minus VB. So for that we have taken, this is VAB, this is VAC AD section, that is VAC, this is VCD, VDE and VF, VFB. These are the voltages of different sections. So by substituting voltage, that means current multiplied by resistance value in each section, current multiplied by resistance value in each section, we substituted. Finally we got IA is like this. So by using this IA value, we back substituted in these, finally we got each section current. So here we observe that in these two sections negative value is given. So with that we can say the actually IEF is flowing like this and this current is also flowing like this. So finally this is feeding current like this and A point is feeding current like this. So a minimum voltage will occur at this point E. To calculate voltage at point E, we have taken VAE, that is voltage at AC, CD, DE sections, we calculated. With that we can say what is the minimum voltage of the distributor, that is at point E, we can calculate like this. So this is one of the simplest numerical problem feeding at both ends. So we calculated voltage drop calculations and numerical on a DC distributor in this session. Thank you.